All right. I believe we are live and live. Welcome everyone to Big Abe's Network Emporium, where we do networking labs, topologies, things that get you going in your network career. Today, our topic is going to be multicast over IPSec VPN. First, give you a little small rundown of IPSec. IPSec is an encrypted unicast IP tunnel. What it can be used as a site-to-site where you're extending connections. Like if you look at my topology here, where if I wanted to extend and allow this east branch, let's say you had a branch facility, to be able to talk to your headquarters facility and have their own IP address space, and then be able to share documents, do collaborative things. It can do it that way. It's unicast. It's encrypted. You have different ways you encrypt it. You can encrypt it with DES, triple DES, AES. You can hash it out. So it's just a way to make sure that traffic, you can use, I guess, general internet traffic to be able to communicate back with your home office. It's a cheaper way because normally you would have something like an MPLS circuit there, and those can be costly. Where if you get like just a general business class internet where you're sitting at 100 meg, 200, 300, 500 meg, will be cheaper than just a 25 meg MPLS circuit. So that's the site-to-site part. Then there's also a client to server type of IPSec VPN, and that's where you do a remote VPN where you're at home, you start up a VPN client, and then you connect into your home office. Hold on one second, I have a call coming through. I'm gonna step away for a second. This is my parents, so hold on one second. I will be right back. Hello. Yes, sir. Uh-huh. All right. Okay. Sorry about that, everyone, but I'm back and had to take that telephone call. But I'm back. So, as I was saying before, you can do a client to gateway IPSec VPN, which would be your normal VPN. Most people nowadays use SSL VPN because you don't have to worry about ports being open through if you went to another business and did an IPSec VPN tunnel, or if you went to the library and tried to do a remote IPSec VPN tunnel, you don't have to worry about ports and protocols being open because most people are going to allow 443 out. So let's get into this topology. In this topology here, we have a headquarters location, and it's going to have two VLANs, VLAN 10 and VLAN 20. It's going to be connected, coming from a multi-layer switch we're using the 37, I think it's a 3725 with the Ethernet switch module in there. Each of our routers for the headquarters, for the East facility and the West facility, are CSR 1000 Vs. The internet is being modeled using the CSR 1000 V as well. Each of the sites are going to use BGP to talk, because we're going to simulate the internet as best we can. And each one of the sites and headquarters are going to use EIGRP as their internal dynamic routing protocol. We're going to have, each spot is going to have its own BGP autonomous system. They're going to have their own IP address scoping in there. And then our end goal is going to be the site here from east, the site here west, will be able to receive multicast traffic from one of the clients. I may use the one on VLAN 10, maybe the one on VLAN 20. They will be able to join an IGMP group, get that multicast traffic, and it will be traversing down. When I generate that multicast traffic, these hosts are Windows 7 virtual machines. And I'm going to be using a multicast testing software created by SingleWire. I came across SingleWire at my job because we use their product Informacast to do paging. And so they have a multicast tool that allows you to check to make sure that your network is actually going to pass multicast traffic as you need. So what we're going to do first is we're going to configure all of our layer 3 from an external standpoint. So all of our externally facing interfaces will be configured with their IP addresses, and we'll get BGP going. So let's break into the internet router here and get that going. I might have to go ahead and get these going because I started them up. So they're base config because we're going to configure this thing from the ground up. So let's get all of those going. Solver to these. I'm tell them no because we want to do all the configuration ourselves. So let's pull up the internet router. So I'm going to enable it here. IP routing is going to turn on. Then we're going to go to each one of our interfaces. G1. Let's configure the IP address on that interface. It is 2.2.2.1. And they're going to be /24s. Keep everything real nice and simple. Configure what I normally configure on security-wise on each interface. It's been a practice of mine for I don't know how many years, so it's natural and it's like muscle memory for me to do that. So now we're going to go and configure GI2 /24. And while I'm at it, let me exit out of that and do if I could type right, I might actually be dangerous tonight. 0. That way we don't have to worry about the message to go to the next line. GI2. Shut that interface. Let's go to 3. And this is going to be /24 on that as well. And we'll shut that interface. Now, time to configure BGP. So we have BGP is going to be our autonomous system of 65,000. BGP 5,000. We're going to tell it its neighbors, which is 2.2.2.1. This remote AS is 65,001. Oh, wrong IP address. Oops, my bad. It's a .2. Sorry about that. I looked at it like I was crazy, and it was looking at me like, yeah, I'm crazy. So, yeah, 3.3.2. Remote AS is 6502. 4.4.4.2. And the remote AS is 65003. Now we're going to configure our address family. IPv4 unicast. Network is going to be 2.2.2.0. 3.3.3.0. 2.5.2.5.2.5.0. And network of 4.4.4.0. Let's go. Alright. So that should conclude our router. Oh, actually, I want to do one thing. I want to change my host name on here so I know which router I'm actually on. Write that configuration, save the configuration. Internet's done. Now let's go over here and let's configure. We're going to configure the external layer 3 on 2 separate interfaces, but let's do this. All right, we're going to console in. We should be already fired up on the HQ router. So let's go here and IP routing. And then we're going to change the host name here to HQ RTR. Let's create those interfaces. So interface GI1. This is 2.2.2.2. For our standard security. So shut that interface. Configure interface GI2. 1.1.1/0.4. Shut that interface. Now let me see. So that way it goes to the next line. Now let's configure BGP. We're on autonomous system 65001. Figure out 2 neighbors, which will be 2.2.2.1. You may hear my kid; he's yelling in the background. So now we configure our remote autonomous system of 2.2.2.1 on 65,000. Let's configure our neighbor of 1.1.1.2. You see we already got a BGP adjacency up. Remote AS of 65004. Alright. Let's configure our address family. Unicast. Network of 2.2.2.0 with a 24-bit mask. And 1.1.1.0 with a 24-bit mask. Should be good on that. That one is configured. Close that one out. Now let's go to our east router. And what we need to do is turn IP routing on. Let's change the host name on this. East RTR, and then we're going to go to our console. So it also everything routes like it's supposed to. And let's go ahead and configure those interfaces. GI1. unicast IP address. This is going to be 3.3.3.3.2 and 24-bit mask. Let's no shut that interface. All right. I'm going to get all my layer 3 connectivity for my external facing up first. Make sure that's working before I start moving to my internal. So let's get BGP going. We're going to do 6502. And then we're going to do our neighbor of 3.3.3.1. AS is 65,000. And then we're going to do our address family for unicast. Network of 3.3.3.0 with a 24-bit mask. And then we're going to write memory. That's all we need for BGP on that end. Close that one out. And then we'll come over here to my west router. Take that off. Login synchronous. And we're going to exile that. And then we're going to go to configure IP routing. And then now let's configure each one of our interfaces. Well, our external interface, that is. This is 4.4.4.2. 24-bit mask. Like type today. We'll shut that interface. Now let's configure BGP. Time was 65,003. So let's get our neighbor of 4.4.4.4.1. Remote AS of 65,000. Then we're going to do address family IPv4 unicast. Say the network of 4.4.4.0. Mask. All right. Now, we configure BGP on all of our routers. Oh, change my host name here. West RTR. All right. So now, from this router, let's do show IP BGP topology for all of them. We can see those networks. They're showing there. We can see that this one is local to us. That's next hop. So we should be able to ping 1.1.1.1. And we can. So I mean, we can get all the way to this interface here. So we're good there. And now let's configure here this router. So I may have everything. So I did this before. Okay, good. I did blank it out. All right, so let's configure routing, and then we're going to configure our interface. It's fast Ethernet 00. Broadcast. And we're going to do our IP address of 1.1.1.2 with a 24-bit mask. And we're going to no shut that interface. Logging synchronous. So now we're going to configure BGP. We're at autonomous system over 65,004. Let's configure our neighbor 1.1.1.1. Remote AS of 65,001. Family IPv4 unicast network. We see our BGP adjacency has popped up. So now we're going to tell what network we have here. 1.1.0 with a 24-bit mask. Write that configuration. So now from this router, I should be able to ping 4.4.4.2. Let's see. Did we get it? So show IP BGP. Did we do that right? Let's look and see. Do we have any neighbors? 2.2.2.2 sent receive. Keep live. Okay, so it's there. 4.4.4.2. There we go. Just took a little while. Just took a little bit. So our BGP is done. Now, since we have BGP done and we have all of our externals are talking to each other, but let's make sure we can ping our 3. Yep. So we from here can ping all the way down. We know it can return back, else you would not get a echo reply in the simplest forms. So we have that to go. So now what we want to do is, since we configured that, now we want to configure our VLANs and our internal interfaces here. So what I'm going to do is come in here. And since this is a 3725, you have to use the old deprecated command of the VLAN database. So I'm going to create VLAN 10, name, client, VLAN 10. Create VLAN 20, client, VLAN 20. Exit out of that. Let's save that. Make sure you remember that. Now we're going to come in here and we're going to do let's configure our interfaces. Press 10. And then we give an IP address 2.168.10.1. I'm going to no shut that. We're going to come into VLAN 20. Give this one 20.1. So that's done. That's good. Now, from there, we're going to need to configure a DHCP scope in order for these clients here to get, to get an IP address. So first I'm going to do an excluded. We're going to do the excluded addresses. 192.168.10.10. It's our high excluded address. 2.168.20.1. 2.168.20.10. Make sure we don't get the default router, all that in there. So now let's create a DHCP pool. Give it a name. This is going to be client VLAN 10. And now we're going to configure the network that is on 192.168.10.0. 24-bit mask. Configure the default router. 168.10.1. Then I like to give it a lease of 7 days. And we're going to call the domain name hq.com. So we have that one. Let's put an IHP DHCP pool, client VLAN 20. And then we're going to tell it what network it is, which is the 192.168.20.0/24 network. Default router, 192.168.20.1. We're going to give it a lease of 7 days and a domain name of hq.com. So now, I'll write mem on this one. Save that configuration. Make sure I got my chat window open. Okay. And so now, when we do show IP, DHCP, pool, and client VLAN 10. Alright. And I gotta check one thing, which I think service. I think it was when I have, yep. I gotta turn this service on here. Conf T service DHCP. This is off by default. So now, if I go and I look at the two DHCP pools, let's see, should be leasing out addresses. And my kid is getting ready to come in here. Zane. Let's scale this out. Hey, buddy. What are you doing, Zane? Did your TV turn off?
You need to do another.
Please. Make sure we get DHCP off of those. Make sure.
Daddy.
Yes, Zane. How can I help you, buddy? Got a kid. He's decided to make a guest appearance. So I gotta think. I got my default router in there, my lease. So hold on, let's take a look here. As to why. Oh, my bad. I forgot I hadn't configured everything on there. So hold on. I had momentary brain lapse. So we have this interface here, this FA10. We need to actually trunk the VLANs over. So let's do this. Conf T int FA10. Turn that as a switch port trunk encapsulation .1Q. Switch port trunk mode trunk. Switch trunk allow VLANs. I'm gonna let them all go through. Quicker to do it that way.
Daddy, I want to go.
Hold on for me 1 second. I'll be right back. Gotta go turn the TV back on for the kid. 1 second. Sorry about that. I'm back. All right. So now, if I come here and let's configure this. So we're gonna go port 0. It's gonna be a .1Q trunk. Add. Port 1 is gonna be access. It's gonna access VLAN 10. And port 2 is gonna access VLAN 20. Apply. Okay. And now, let's see if it pulls a DHCP address. Bada bing, bada boom. Realest guy in the room. Turn this into a work network. So now, if we look at both clients here, so we got an IP address here, .12. I'll come here to VLAN 20. And let's do a scaling on this. It's got an IP address because it found a network location. So we have our, and I'm going to do this so we can see which one is which. I'm going to change the background. Oops. I'm going to change it to this one. Save changes. And then we're going to go here. Change the background to here. That way we can tell which machine that we're on. So we see the client on VLAN 10. We'll move this over here. The client on VLAN 10 has an IP address. And if we open up a command prompt, client on VLAN 20 has an IP address as well. So now that we got DHCP there, I'm going to minimize that. And then we're going to come over here to our router, our east router. We're going to configure DHCP on this side as well. So, excluded address of 10.1.1.1 to 10.1.1.10. Now, we're going to configure that interface, GI2. Redirects, proxy, broadcast. I'm going to no shut this interface. 0. I think I already did this one, but alright. So that interface is up. Now we've done our excluded address. Now we need to configure our pool. We're going to call this East Client. We're going to do a network. Our network's going to be 10.1.1.0/24. Default router is 10.1.1.1. Lease of 7 days. And then we're going to give it domain is going to be east.com. So we save that configuration. I think I did it. Okay. Now, if we do a show IP DHCP pool, so that one should get there. Brief. It'll take a few seconds for it to get there. So let's open up this console. View scaling. And let's do this. Config. Renew. So I can speed it up. While we're doing that, I'm going to change this background so we can clearly see what we're dealing with. And this is going to be number 3. Save changes. Get out of that. And we're going to do this one as well. Change its background. This is just so I can, for my sanity purpose, so I know that it's different. 1, 2, 3, and then this is 4. Save changes there. View scaling. So I have to go and look at router. Gotta go configure my interface. On GI2. And 10.1.1.1 on a 24-bit mask. Yep, there we go. Now, these should begin to get an IP address. And there we go. There's 11. There's 12. So we have IP addresses on those. So we're good there. Save this config again just to be on the safe side. I'm gonna move that. Now we can get out of that router. And now we can go into this router. And so what we're gonna do here, we're gonna DHCP excluded IP address of 10.2.1.1 to 10.2.1.10. And we'll do IP DHCP pool. We're gonna call this West Client. So it's a network of 10.2.1.0, 24-bit mask. Default router is 10.2.1.1. We're going to give it a domain of west.com and a lease of 7 days. So now pools. Did it again. GI2. No IP reader. Redirects. No IP proxy. ARP. No IP directed. Broadcast. Hey, mentors. Thanks about that, man. Yeah, it's good to be back streaming. You got to make sure we give that good content. So it's good. I enjoy it. This is fun for me. So now let's configure our IP address. So just catch up. We've gotten layer 3 going for our externally facing interfaces. Now we're getting layer 3 on our internal interfaces. Again, DHCP running on those. So 10.2.1.1. So now, forgot to no shut that interface. So that interface should be coming up here. Show IP DHCP pool. Now that has come up, we should be getting a lease here pretty soon, but I can always come here and let's get this rolling a little bit faster. So I got a top. I need to console into that. Use scaling. Of course, I have to change the background so I can ensure that I can remember which one I'm on. So this one is 5. I'm gonna come in here, console, change my scaling on this, personalize it, change my background, and we're gonna do 6. There we go. Okay, so now if I do say now. And boom. IP addresses. So we have our client connectivity. All of them are getting DHCP addresses. All 6 machines, as you can see. I think I left it. Yeah, all 3. Let's bring this one back up. Config. And so you can see all of our machines at each location. I should go that big. Our location at HQ, East Branch, West Branch. All right. Yeah, definitely mentors. Yeah, I heard about that hurricane. I think it's like a category, like you said, it's category 4. Yeah, definitely prayers going out to all those people. Make sure they stay safe. You guys, heed the warnings. If they tell you to leave, leave. Take your precious belongings, those things that you can't take, that you can't take, that you can't leave or recreate, i.e. your family, some, maybe some photos, personal items like that. Don't try to take the entire house, but get to safety. Your life is worth more than those items. The house, the cars, all that, those can be replaced. But your life and those precious memories that you have, those cannot. All right. So we have that. So now since we got DHCP going, let's get some natting going. So that's going to be our next thing to do is to get some natting going. So let's come over here. And we're going to console into here. Let's create an IP. Let's create an access list. Extend it. I'm going to call it, I'm going to give it a number. We're going to give it 100. And then permit 10, what, no, I'm sorry, I'm on HQ, so 192.168.10.0 versus mask. Oh wait, IP, sorry. Hold on. I know I left something out. Yeah, IP 192.168.10.0, and then should be wildcard 0.2.5 to any, and then we also want to permit IP of 192.168.20.0. Chat window back up going. Any. So then we have a list. Now we're going to configure a NAT pool. IP NAT. And we're going to kill a pool. And we're going to call the pool NAT. NAT it. And start IP address is going to be our external interface, which is 1.1.1.2, 1.1.1.2. It's going to be our end, and then we're going to have a prefix length of 24, because that's what that IP address is. Now we need to do an IP NAT source. It's going to be our list of, and we did that list is 100, I believe it was. Yeah, 100. And then we're going to tell it that the pool is, what did I name it? How do I make sure I get my pool right? NAT it. And then we're going to make it an overload translation. Now, we need to, well, I have to pass my written first. So I'm looking to do my written this year, and then early early to mid next year do my lab. Yeah, I took my written at Cisco Live and didn't go as well as I hoped for. But you know, this means I got to get back up on the horse and get that thing going. So hopefully the next, I'm gonna claim it now. The next time will be a pass, and then I will be scheduling my lab because my wife says she wants a vacation, and that'll coincide with me taking my lab exam. All right, so we've got our overload pool here. So now we need to go to our FA00 and make this NAT outside. And int FA, then int, and we gotta go to each one of our VLANs and tell it that it is the inside NAT. And then we're gonna p NAT inside. So now, if we do an IP NAT translate, show IP NAT translations. Which first, I'm gonna have to actually create some traffic. So if we come over here, we should be able to go to this VLAN here and ping anything, but I'm gonna go all the way down and ping this interface down here. So 3.3. Oops, my scroll lock is acting funny. So ping 3.3.3.1. Let's see if we get a translation. What am I missing here? Show run section NAT. I got my pool. I got my prefix length. I got my source. And it's telling us overloading. Zero. You're not outside. What am I missing here? So I got IP NAT. IP NAT inside source. This guy forgot that. So let's get I'm gonna get a Teams ping started. VNet source list 100 pool NAT it. I gotta make sure I name it. Where's my pool? Yep, NAT it. NAT it. Overload. Boom. Smart guy I am sometimes. Let me get rid of this right here. Copy. Paste. So now we should be good there. So now just to show this working here, it should be working on this one as well. So if I go 3.3.3.2, we're pinging. We're good there. Okay, all right. So now let's configure our NAT down here on our east router. Let's do an IP access list extended 100 permit IP 10.1.1.0 0.0.0.255. It's anywhere. That's that. Now we need to create our IP NAT pool. I'm gonna call it NAT. We're gonna keep it simple. And then the start IP address is going to be the external interface here, which is 3.3.3.2. And it's going to end at 3.3.3.2, prefix length 24. So it's our pool. Then we're going to create our IP NAT inside source list natted pool. Wait, I did that right. List 100, and then pool of natted, and then we want to overload it, and then we should be able to go to the interface of GI2 and say IP NAT inside, then int GI1, and do IP NAT outside. So now we should be able to come, let me stop that one. We should be able to come to the east client and ping 1.1.1.1.2. Boom. That's good. Yeah, I did. This is my topology. It's a brainchild of mine. So, no, I actually haven't gotten into GitHub Mentors. I'm gonna need to do that. I see everybody is into GitHub. I have a fellow coworker. He's into GitHub as well. So I'm probably gonna get that. If you have any links, tips on how to do that, just shoot those over to me. I want to get into that. So, help me out, and so that I can do that. All right, so we're able to do from there. Now, say it's configuration. Now we're gonna come over here to our West router, and we're gonna create IP access list extended 100 permit IP 1.2.1. No, it's 10. Sorry, 10.2.1.0.0.0.255 to anywhere. Then we're going to create IP NAT pool. It. Start IP address is going to be 4.4.4.2, end at 4.4.4.2, 24 with a prefix length of 24. Then what we're going to do is that IP NAT inside source. I can't believe I keep forgetting. Source list of 100, pool of natted, and then we're going to overload that. Then we're going to come in int GI1, IP NAT outside, int GI2, IP NAT inside. Say that configuration. So now we should be able to come over to the West client. Let me move that around. So we got the West client here, and now the West client should be able to ping 1.1, 1.1.1.2. Boom. So we've done our external layer 3, our internal layer 3, DHCP server to give DHCP addresses to those clients, which are Windows 7 clients. And we've also done NAT, so then these can ping to us. So now we have full connectivity as far as external, or I should say private to public, and from public to public. Now we need to get private to private going. And the way to get that going will be for an IPSec VPN tunnel. So now what I want to do is I'm going to go to each one of these routers. So let's go HQ first. I'm going to use EIGRP. So router EIGRP, we're going to give it the EIGRP process number 100. No auto summary. Network 192.168.10.0. And then a network of 192.168.20.0. Alright. Right, ma'am, on that. Come to my West router. Network of 10.2.1.0. Save it there. And then we're going to come to the East router. This is 10.1.1.0, 0.0.0.255. All right. So we have those configured, EIGRP. Now, what I'm going to do is let's create the IPSec VPN tunnels. So what we have to do to create those IPSec VPN tunnels, we got to create a crypto map. We're going to have to create. We're going to tell what our ISACAMP policy is, and then we're also going to do a transform set so we can tell it how to encrypt and how to hash everything out. Now, what I'm going to do with this to make it, since I want to do a dynamic routing protocol, this is where the multicast comes in. Since we know that EIGRP talks about multicast, in order for me to form these adjacencies, I'm going to need to get multicast to go across. So here's what we're going to do. We need to make, in any IPSec VPN tunnel, you have to have what's known as, they call it, interesting traffic. What do you want to encrypt? So in order to encrypt this tunnel, so I can do it one of two ways. If I did a pure GRE tunnel, I can make a GRE tunnel go across the internet. Of course, it'll be unencrypted, so all your information is out there. Or what I'm going to do is I'm going to create an IPSec VPN tunnel, put the GRE tunnel on top of that, so then multicast can ride over that IPSec VPN tunnel through that GRE tunnel. So all of our traffic is encrypted. So what we're going to do here is we're going to come on the HQ router, and I'm going to create my tunnels. So what I need to do is I need to first create an access control list. So now we're going to do IP access list extended, and we're going to do let's say 120. So then what we need to do is, since the traffic is going to be the encryption of our GRE tunnel, and for the GRE tunnel to work, it needs to be from our external, our public facing IP addresses. What we're going to do is we're going to define the traffic as, excuse me, we're going to define it as, we're going to do permit GRE, and we're going to go from, we need to go from this interface, move this over here, we need to go from the FA00 interface of our HQ multi-layer switch to the GI1 interface of both of our routers. So we're going to do a permit GRE from host 1.1.1.2 to host 3.3.3.2. Then we're going to do permit GRE from host 1.1.1.2. I think I want to do a separate. No, we're good. We're good. We're good. Host 4.4.4.2. So we have that. Now let's create our crypto map. Crypto map, and we're gonna call this. What are we gonna call this map? Let's call it the map. I like that. The map. Now, this is gonna be I forgot. I'm missing a step here. Actually, hold on. I don't want to do my map first. I want to do my tunnel interface first. I want to do my GRE tunnel interface first. Place tunnel 0. And I'm going to do 2 tunnels, one for each site. So, yeah, I'm going to have a tunnel going from here to here and a tunnel going from here to here. So let's create an IP address. And for this tunnel IP address, let's give it 172.16.1.1 0. And then tunnel source, it's going to be 1.1.1.2. And then the tunnel destination is going to be, for this one's going to be the east router. So we're going to make it 3.3.3.2. And of course that, all right, bring that tunnel interface up. Tunnel 1, the address 172.16.2.1, 0. So tunnel source 1.1.1.2. Tunnel destination. It's going to be 4.4.4.2. Bring that up. Now, let's create our crypto IPSec policy and priority protection. So let's do 10. Should be fine. Then we're going to do, I need to set a hash SHA. And then I want to do a authentication of pre-shared key. And then I think that should do it for that piece there. Now let's do, let's make that key. Crypto IPSec key. And I think I have to tell it that it's going to be unencrypted. I'm going to make it unencrypted. This is for, we're going to make it the wonderful password of everybody's favorite password of Cisco 123. And then define your keyword address. And the peer address of 3.3.3.2. And then we need to do a crypto IPSec key 0 Cisco 123 address of 4.4.4.2. So we got our 2 keys. Now we need to create a transform set. So crypto, I think it's IPSec transform set. And we're going to call it my set. And then we're going to do, ESP AES, and then we're gonna do ESP SHA HMAC. Yes, yes, kiddo. My kids ask questions. Yes, can I help you? Okay. See you, kiddo. My kid is having fun coming in to talk to daddy. All right. So now let's create my crypto map. And we're gonna call it GRE map. And we're gonna make this we gotta do a sequence here. Sequence of 10 IPSec IceCamp. Where should be it? And then of course his name to set up here. So now we're gonna set up here of 3.3.3.2 here, Abram. 3.3.3.2. Then we're gonna do a transform set. And I named that. What did I name that? Set. My set. Now we need to match the address in. I think I did it as 120. I want to say. Go back up and look again. Did I create that? Yeah, 120. Okay. All right. So it should be good there. So this should be our map. So then now I need to come to interface FA0/0 crypto map, my map, and that will set it to tell it that it can do the map there. So crypto map, my map doesn't exist. Hold on, what did I call that? GRE map. Whoops. GRE map. There we go. IceCamp is on. Now, if we come over here to the East branch, so I'm going to create IP access list extended 120. Permit GRE host 3.3.3.2 to host 1.1.1.2. Get out of that. So we created that. I'm gonna create my tunnel interface. Tunnel 0. IP address. 172.16.1.2. Then I need to do tunnel source 3.3.3.2. Tunnel destination 1.1.1.2. And then I should be able to do oops. Alright, so I should be able to do that. So that. Now let's create my crypto IceCamp policy 10. Authentication pre-share. Exit out of that. Crypto IPSec. Let's get the key. Yeah, let's do the key. Okay, let's see. I would say I'm the multicast guru, mentors, but I have done a decent amount of multicast. I'm trying to think who. I think somebody else in the group has done a way more multicast and way more complex than I have. So I can chime in, but I wouldn't necessarily call myself a guru by any stretch. All right. So now let's configure my key. It's gonna be that Cisco 123. Oh yeah, I'm tripping. 3.1.1.1.2. I keep forgetting. So that should be that. We're gonna create a key. Now let's create the crypto IPSec transform set, and we're gonna call it my set. I think that's what I did on it. Did I call that one my set? So run section crypto. I think I call it my set. I'm just gonna make sure I call it my set. Yep, my set. And let's make sure we get that. AES, ESP, SHA, HMAC. Excuse me. So we've got our, we did our, okay, so we got that. Now we need to do the crypto map, GRE map, 10, IPSec IPSec set peer 1.1.1.2 set transform set my set, and then match IP address 120 match address of 120, and then let's exit this, and then we're gonna go to int gr1, and we're gonna do crypto map Abram GRE map. Nice, camp is on. All right, so that should be good to go. So we should have it there. Now, show hold on, I gotta remember. The brain lapse. Pull up one of my notes here. Crypto. I think it's crypto IPSec SA. Okay. Show crypto IPSec SA. So we don't have anything. Oh, we need to generate that traffic. So what I'm going to do is I'm going to come to this conf t, and then I'm going to turn on IP multicast routing. IP multicast routing. Distributed. Got different type of router. And then what we're gonna do is I'm gonna come to router EIGRP 100, and then do the network of 172.16.1.0, 0.0.255, and then I'm going to come to router, EIGRP 100, network 172.16.1.0, 0.0.255, and there's an adjacency. Because we turned the multicast on, moving towards my, let's see, run smooth. I'm using CSR 1000 Vs for my routers, and then which are represented by the HQ router, the internet, east router, west router. The multi-layer switches are 3725, which is the standard iOS image, running through Dynamips. The reason why mine doesn't strain that much, I'm running everything off of solid state drives, and my machine is a dual Xeon machine, so it's 16 cores, 32 threads, and then I have 128 gigs of RAM, so that's why it runs pretty smoothly. So now we get our router adjacency. I'm going to write mem on this, because we know the tunnel's up, else those wouldn't have came through. So now if I do show IPS, you see now I have, from those two, it's actually going. So show crypto ISACamp SA. Now we see what we have is there. But if I do a show IP route, let's watch something. Wait a minute, over here, look at that 10 route. I'm saying the 192.168 route. We've learned that via, as we know, if you see that D, you know it's EIGRP. So now we know that we have formed that router. We have formed an EIGRP adjacency. Now we're getting routes. So we should, if I come back here and I get on the East computer, this is the East computer down here. If I ping 192.168.10.1, boom, there we go. Now I'm going to show you something as well. If we look here, now if I do start a capture on that router there, let Wireshark come up. Oh, Wireshark went to my other screen. So let's bring Wireshark up. Come on, Wireshark. There we go. As you can see, it's all ESP. You're not gonna see anything. It's just a bunch of gobbledygook. So it's nothing. So those are to being able to talk to each other. They're being able to talk to each other across the IPSec VPN tunnel, that's where this ESP comes from. And from that, since I turned multicast routing on and added those, have that GRE tunnel, they can go across those tunnels because I put the tunnel IP address into EIGRP. Now it looks like it's a point-to-point link. And now it learns about these two networks here. But guess what? This is going over our general internet and nobody knows what's going on because it is encrypted. It's just nothing. A bunch of gobbledygook. So I'm going to stop that. I'm going to keep that capture going. And then I'm going to start capture here on this interface. So we have two Wireshark windows going. Trying to make sure it doesn't get too cluttered. It's east, and then my west router came over here. So as you can see, all this doing is talking BGP right now. So if we come over to our HQ router, show run it, sharpie int brief. We see that we have our external, our two VLANs. We have another tunnel here, 2.1. So now we need to actually show run section crypto. where I have this here, I'm just going to regenerate it, give it to 20, and now I can do the same thing here. So now, Alt-T, we're going to do crypto map, GRE map 20, IPSec ISACamp. We're going to set the peer to 4.4.4.4.2. We're going to set the transform set to my set. And then we're going to match the address on 120. And we already have the crypto map in place on the external interface. Let's say, mentors, this would be fun to topology add Kali and experiment some pen testing. That could be pretty fun there. That could be interesting. That could be interesting. We may have to do that. Get together and collaborate on how we can actually do that. You know, I'm all for it. I actually have my brother. He's actually a certified pen tester. He has his certified ethical hacker certification, and he does security. So he told me about Kali Linux, and I've heard you talk about Kali Linux there. I mean, we could do that. We definitely could do that. All right, so we've got this multi-layer switch. We've configured that, and you can see over here nothing but BGP talking. So let's come over here and let's go to our West router, which I have 2 of those open, which I don't need. Now, T, let's do it ton 0. IP address 172.16.2.2. So I think I set that one to 2.1. Yep, 2.2. And then we're going to do it's a /24. Keep everything as simple as possible. Then we're going to tunnel source is 4.4.4.2. Tunnel destination is going to be 1.1.1.2. And we're going to no shut that interface. Now we have to come through and create our access list. IP access list extended 120. Permit GRE from 4.4. Host of 4.4.4.2 to host 1.1.1.2. And we're going to get out of that. And then we're going to create crypto ISACamp policy 10 authentication pre-share. Should be good on that. Yeah, we should be good on that. All right, and then we're going to do a crypto, if I can spell, crypto ISACamp. We're going to create our key of, I think we're going to do Cisco 123. Address of 1.1.1.2. Then we need to do crypto IPSec transform set, my set, and we're gonna do ESP AES and ESP SHA HMAC. That. Now we're going to do a crypto map, GRE map, 10 IPSec ISACamp. Set the peer to 1.1.1.2. Set the transform set to my set. Match the IP address on access list of 120. Then we're going to come here and we're going to do the Interface GI1 crypto map, GRE map. So now that crypto map is there, ISACamp is on. As you can see, still just that. We don't have any traffic yet. But hold on. We're going to make it. Yeah, tab is your friend. Sometimes I forget to tab. Sometimes I tab too much. Sometimes I get the letters wrong and try to tab, and it continues to be wrong. So if we do int ton 0, wait, I'm sorry. I need to come to router EIGRP 100 network 172.16.2.0. So that's in there. All right, then. Now we got to come over here, because if we do a show run int ton 1, we can see that, or I'm sorry, show run section. There's ISACamp starting. EIGRP, Abram. Sometimes I forget. So now when we do that run, we don't see that network. So if we come in here and we come T, router EIGRP 100, and now we set our network 172.16.2.0. Come on, baby. 2.0. 2.0. Fail process of quick mode fail with peer. Show run GI1. Show run int FA0 so 0. I got the crypto map on there. Show run int GI1. I may have to do a different let's see, quick mode is not coming up, so I gotta make my brain think. I may have to take the I know what I'm gonna have to do. I'm gonna have to come in here and create a different show run section crypto. I'm gonna have to create a different IP address. So let's go to show access lists. So if I come here, conf t IP access. So I got matches there. Process show access list. 112 matches there. Show run section crypto, and then show run section crypto, and make sure that one of my let's see if I missed something. So there's my key. I'm in my pre-share. ESP, AS, ESP, Shamak. And then crypto map there. I said match up, and then that. So my quick mode is off somewhere. Section multicast. Did I turn it on? Need that on, but my quick mode is failing. Processing a quick mode fail with peer at 4.4.4.2. So let me go back and double check and make sure that I have alright, so then crypto map, area map, IPSec, transfer set my set, match IP addresses in there. Show run in tunnel 0. Show run in tunnel 1. Destination 2 to 2, so that's right. Make sure I got everything. Yeah, that's right. So let's see if I can figure out identity protection processing a quick Azure Camp mode failure. So process a quick mode fail with peer at 4.4.4.2. So show access list. I'm hitting that list. Where am I going wrong here? So I've got my crypto map, GRE map, so that's there. That's there. So let's take a look. We're missing, I know I'm missing something super simple. Let me go look at the East router. I'm going to double check on my East router. Show run section crypto. IP address, IPSec mode tunnel. It is, let's go from pre-share, key, transform set the peer, my set, my GRE map. Okay. And session crypto. I got so GRE map 10, that's count, set there. What, am I missing something? I don't think I'm missing anything. Got my key, my policy, source and destination. Let's break that out. You know, I'm gonna break this out. Processing the quick mode fail. Show access list. It's going to the right thing, so show access list 37 matches 4.4.4.2 to host 1.1.1.2. So let's take that, let's do this. Show access list. So what we're gonna do, let's take this out and give a different, I'm gonna give a different access list. IP access list extend, I'm gonna break that out 130. Permit GRE host 1.1.1.2 to host 4.4.4.2. Exit that. IP access list extended 120. I'm gonna take this out. It shouldn't matter. Copy, paste. Take that out. And then I'm going to go to my crypto map here and match address of 130. I think that's what I did. Yeah. 130. There we go. I had a feeling it was the access control list. All right, we're back on track now. Now we got ESP going here. So if I do a show crypto IPSec SA, I got that. And then if I do show crypto IceCamp SA, now I have two tunnels configured there. So that's what it was. It was the access control list. So let me say that configuration. Run on all those. So now that we have those in there, if I do on the west route, and I'll show IP route, watch what happens here. Wait a minute. I have the 192.168.10.20. And wait a minute, I have the 10.1 as well. So I'm learning all these over that tunnel. So now from there, I should be able to come over to, I don't think I have do I have a continuous ping going somewhere? No. So I should be able to come over here, ping 192.168.10.1. Boom. I might have to pop out the chat a little bit. Yeah, but I appreciate Q-Cat. It was the access control list. It needed to be, since it's technically an IPSec VPN tunnel, they have to match. And so since it saw two things in the access control list, and that my second tunnel was below it, it was throwing an error. So I said, let me remove it out and make it where so that the access lists match on both sides. Because they're supposed to match on both sides. The interesting traffic should match on both sides. And so since I had one up, and it was hidden it was going through the access control list and hitting the first one and the second one, was like, those don't match. It's not two. Since it hit the first one on the first tunnel I made, that's why that one came up easy, because now that made it match. But since it saw there was a second one, went to the second, it was looking for two, and there wasn't two. So I just stripped out that other piece of the access control list and then made a separate one, and that brought it all up. So now you can see from the west client, we are able to ping up that way. Now, we've done that. Now the next thing we need to do is configure, we need to configure our multicast. So I've turned multicast around on all the routers. So let's double check that. Section multicast, make sure multicast routing is turned on. So now what we're going to do is we're going to, I'm going to configure a loopback address, because that's going to serve, when you're doing multicast, you need to have a rendezvous point. The rendezvous point can be statically set, or you can have it dynamically find, which is the EIGRP. So that's what I'm going to do, is I'm going to figure EIGRP so that it's dynamic. I don't have to set it on any of my other routers. They're going to know what's the rendezvous point for our multicast network. So guidelines tell you should, if you want to make a rendezvous, you should make your rendezvous point address for multicast should be a loopback address. It should be an address that they prefer loopbacks, because loopbacks don't go down. Unless you administratively shut them down, they're always up. So let's create our loopback address, a loopback 0. And then IP address 192.168.254.1. And we're going to give it a /32. Now, here's the key to make multicast work. Actually, we want to do it in PIM sparse mode. That's the most common now is PIM sparse mode. So let's do PIM sparse mode. That's going to make it talk multicast. Now you see that DR changed from neighbor from there to there. So that's where we're going here. So now let's get this rendezvous point going. We're going to do I gotta do this. So now we're gonna tell it. We gave it an IP address. We turned PIM sparse mode on our loopback interface. Now we're gonna do IP PIM auto RP listener IP PIM. We're gonna make it send RP announce, and then we're going to tell it that it's going to come from loopback 0 and a scope of 16. All right, so that should be there. Now what you have to do is for anything to talk, get my chat going, anything to talk multicast, it needs to be PIM sparse mode on that interface, either your layer 3 interface, which would be gigabit 00 whatever, or on an SVI. Excuse me. Since we're using SVIs here, we're gonna come in and go int VLAN 10 IP PIM sparse mode, int VLAN 20 IP PIM sparse mode. All right, man. Now we're going to come on our east, so IP int brief, and we're going to do this interface and GI2 IP PIM sparse mode, and then we're going to come to our west, int GI2 IP PIM sparse mode, and then that was gonna go. And now we have that. Now let's do this. This is where we're going. This is where it gets interesting. So we know that we've got our IPSec going, which we have GRE running over top, and then we turn EIGRP on to do dynamic routing. So we know that's going across because we know EIGRP uses multicast for its route as one of its 2 advertised routes. So now what we need to do is let's come over to client 10. I have this program here. We have something called where I work. We use a program called it's made by a company called SingleWire. And it's called Informacast. It's used for paging. They come with this nice little small, lightweight multicast tester to see if multicast is working. So I'm going to make client 10 on VLAN 10 be the server. So it's going to send out on 239.0.1.2. If I come here, run the same program, and run it in client mode, it should catch it. Let's see. Yeah, I'm gonna client VLAN 20. Did I turn it on VLAN 20? On our multi-layer switch, I did. IPM sparse mode, which is right. Show run. It's loopback 0. It's in sparse mode. So now we gotta make this talk. I'm missing a one piece in my multicast, and let me check. gotta make my brain think. I did show run section PM RP listener loopback 0. I got it on loopback 0. That's up. Dummy me. It's my routing protocol. As you see, it can't go because it doesn't know how to route to use that rendezvous point, even though it's on the same multi-layered switch. So we should be able to do network 192.168.254 dot 1 and 0.0.0.0. Oops. I should get that there. Let me make sure I can ping 192.168.254.1.1. I can ping it. I'm missing one piece. So I gotta think, what am I missing inside of that? I'm missing something. Okay, so hold on. Yeah. RP listener, then RP PM send RP discovery loopback 0 scope 16. I'm missing something. I'm missing. I know. No. I don't want to. I got my brain think. I'm missing one piece, ladies and gentlemen, and I gotta think what piece I'm missing. There we go. It took its dear sweet precious time. There we go. So now it took a second. So now show IP IGMP groups, and now I see that group is coming from there. It's joined. That one is joining that group. So then, if I do show IP IGMP, I'm not snooping. Show IP mroute. So now I get my star comma G. That's the group. And then I have what's actually participating and listen to that. There we go. I knew I missed one small tiny piece there. One small tiny piece. So now let's watch the metrics. We see on the same layer 3 router multi-layer device, you are able to actually receive those traffic. So now if we come over to the east side, and say I want to be a client, it can't receive multicast traffic. So we come over here and we look and we say, let's look at, oh, the wrong one, so let me do this. So GI2. Well, we have sparse mode there. Why is it not working? We need to have sparse mode on our tunnel interface to allow it to go across. So we should be able to go here, tunnel 0, and then we're gonna do IPPM sparse mode, Abram. All right, and you go, okay, we done that. And you go, still not working. Why is this not working? And you go, why is it not working? So now what we're gonna do, we go, if I do a show IPPM neighbors, I got nothing. Oh, if we come back over to our other side of the tunnel router, show run int-ton 0, it doesn't have it on there. So now if we come here, int-ton 0, IPPM sparse mode, those should become an IPPM. Boom, we got that up. Wait for it. Come on. Get across that tunnel. All right, so we got our PIM neighbors up. That's right, configuration there. All right. Oh, no. Okay, so we should be good there. Why are you not? To multicast client. Show IP, IGMP groups. I'm learning it. Show IP mroute. It should be going out of the tunnel interface. Sparse mode. Sparse mode. I shouldn't have to do anything on those routers. Neighbor change. Sparse mode there. Let's see. Run to. So I'm not receiving multi-class on that one. All right. So I got a Sharpie pen neighbor. So tunnel 0 is my PIM neighbor. So I shouldn't have to do any let me think. missing. I'm missing one piece, guys. I'm missing one piece here, and I know. I'm missing one piece. PMRP mapping. PM to rendezvous. Okay, so I'm gonna need. So let me go back. Let me go back to my here. Show run section PM. I know I'm missing one piece, so I gotta announce, and I got a discovery. Hold on. Got on look back 0. I'm missing one piece, ladies and gentlemen. One piece. And I'm just trying to figure out which piece it is. One piece, and I know I successfully did the lab, so I'm missing literally one piece. Let me see. Let me see. Missing one piece. One piece. Let me go back. So. It's an RP discovery. Hold on. I need to take that out. And then sparse mode. Multicast is on that one. And come over to the east. Multicast is on that one. So let me go back. So I've got two tunnels, two VLANs. 2 tunnels, 2 VLANs. 2 tunnels, 2 VLANs. Oh. And then we'll loop back. Alright, so loop back is in tunnel 1, tunnel 0 sparse mode. Smoke trunk. Sparse mode there. BGP. I've got that route. EIGRP. Okay. I'm missing one piece. And I know. Missing one piece, and let's see. Hey, what's going on, show? So I'm trying to figure out. I'm missing one piece, so I'm sending my auto RP announce. Sending my auto RP discovery. I'm missing one piece. And I just got to figure out what that one piece is. Loopback is going through there. It's using sparse mode. Everybody's using sparse mode. It's not getting my rendezvous point. But what am I missing? I'm missing one piece. This gotta be. I'm missing one piece, and it's not getting a rendezvous point. I have a neighbor, which is my tunnel 0. So I have a neighbor. It says my incoming interface is null. My outgoing interface is GI2. So ping it, no problem. Let's see what we got here. Show. Enable sparse mode. For some reason, it's not finding. Where's enable? No, I didn't create any IGMP groups. They should find it automatic because it should use the rendezvous point, the auto rendezvous point that I have established here. So show run it section PM right here. where I have the announce the loopback 0. So what am I missing? What am I missing? I'm missing a piece. And I gotta remember what it is. Let me see. Let me pop out my chat here. Pop out. Pop out, chat. So, yeah, tunnel 1. Tunnel 1. It's in sparse mode, and tunnel 2. So, tunnel 0. So both of them are in sparse mode. Hold on. Empty tunnel 0. I'm missing tunnel mode. I shouldn't need it though. So tunnel. So I'll just do that on 0. Yeah, they can ping it. If I come here, ping 192.168.254.1, they can all get to it. What did I do? I know I'm missing one tiny piece. And East client, West client, West client. We'll just start you up just for the sake of it. No multicast traffic. It's receiving inventory results. So I think I'm missing one tiny piece. Yeah, it's not. That's a problem. Show IP PIM RP. It does not find a run every point, which it should do an auto. You know what? Hold on. Wait. Show run section PIM. I'm going to. If I take out the Yep, using RP. So I gotta think of my. No, because it should be. I've used using. I'm used to doing sparse mode. I I actually configured this lab yesterday, and I did it during using sparse mode. Announce. It's supposed to be. If I tell it loop back 0. Scope. What did I do? I blanked out my. Yeah, because I did it. I'm missing. I can change it, but I had it using sparse mode yesterday. Like I completely configured it using sparse mode yesterday. Now I know if I did this, and I don't want to do this, but 68.254.1. I can make it do that. That's the easy way, but I don't want to do that. I didn't want to do that. It should automatically. Shouldn't have to. I can do that. It's GI2 IPPM. Let me see that. Let me stop it because it's thinking that it can. I want to restart. Now it knows it. All right, so let me go to west. Let me go to the west side, to the west router. Tunnel 0, IPPM, dense mode, and then NGL2 in dense mode. Then let's go to the tunnel 0 for invalid rendezvous point. Tunnel 1 in dense mode. And then VLAN 10 IPPM dense mode and VLAN 20 IPPM dense mode. And LO 0 IPPM dense mode. Oh, sparse dense mode. Sparse dense mode. That's on what That's VLAN 10. VLAN 20. Tunnel times 0. 1. Section PM, make sure I don't have anything extra. What's this one? 1, 2, 3, 4, 5. Okay, so that's work. Two interfaces, the tunnel and that one. So it's still to no multicast traffic. East. Listener. Let's see if I can. What did he do? Mapping packets. And do I need to put it on? So, he's got on sparse mode, DR change. He's got everything on sparse mode on all interfaces. Crazy thing is I had this working yesterday. Alright, hold on. Tunnel 1 on West. Okay, there you go. I promise you I had this working on sparse mode yesterday. Okay, that's interesting. Should duplicate this out yesterday. Oh, well, it's working. But that's not how I originally designed it to work, because it actually did work yesterday using sparse mode with the auto RP listener. So I got to figure out what happened on that one. Maybe. Hold on. Let's get crazy here. Let's get crazy here. I'm going to. Let's get extra crazy. Because, well, the Windows box that I have on here, I made sure it worked yesterday, and it saved the changes. That's why, like, that's still here. Because I actually, just to be on the safe side, well, it turned the firewall back on. I'll take that back. And Windows turned itself back on. Let me double check the other ones. Normally it's not a problem, but yeah. So yeah, Windows refreshed itself. Great. Let me try something here. I'm going to remove section PM. I think GR2. I want to try something. Sparse mode. Turn 0 IPPM sparse mode. So it's my tunnel. That's that one. I'm gonna do that. Let's see. So if I do PM sparse mode, sparse mode. Come over here. Run section PM. I'm gonna change all those back. VLAN 10 IPPM sparse mode, VLAN 20 IPPM sparse mode, int 10 0 IPPM sparse mode, int 10 1 IPPM sparse mode, int LO0 IPPM sparse mode. There's a number of sparse modes on there. Sparse mode. So now if I do show IP if I could spell today. Elected via auto RP expires in 247. Alright, so now can I clear it that way? Clear. Yeah. So PM to group mappings. PM. Elected via auto RP. So, looks like show IP PM RP mapping. All right, show. Thanks for joining in, man. So it looks like once it's finding it again. I think it was the auto RP listener I was missing on each router. So it was rejecting it. I think that's what it was doing. It was rejected because now it's finding being the auto RP, and I've cleared it out to make sure. So now I should still be able to go. If I come here, run it, do as the server, I should be able to come to the west side and run it as a client. Oh, I did that wrong. 2, not 3. Two. Boom. Yep. So I think that's what it was. I think it was the auto RP listener need to be on each one because it wouldn't listen to tell. It was sending the announcement, but it wasn't accepting the announcement. So by turning that on, because now since I've cleared it and nothing is using dense mode anymore, it's the RP listener. So it needed the RP listener on each one to actually accept those packets. So now West is receiving it. East should be able to receive it. And there we go. We got it. So, all right, that works. Man, that took a little bit longer than I thought it was. But, you know, it's not like having a little issues to get the brain going, and none like having some help. Appreciate you guys, mentors, show for the help on that one. But I think that's what it was, is the fact that the auto RP listener wasn't on each one of the branch routers. And since it wasn't there, it was rejecting the auto RP announcements that was coming from the multi-layer switch. So just to recap, I had to put IPPM auto RP listener here and here, so that when this router here, or multi-layer switch, was actually announcing itself as the auto RP, it actually would listen to it and say, okay, I know where the rendezvous point is. So I think that's good. We've successfully got multicast going over IPSec VPN by using GRE to encapsulate the packets, so that multicast can actually go across the IPSec VPN tunnel, and that allowed us to have a dynamic routing protocol, EIGRP, and it also allowed us to have multicast coming from HQ and being received down here east. Yeah, thanks, mentors. Appreciate it. Appreciate the help. I'll take as much help as I possibly can get. That's why I love this this Discord. We, you know, everybody chimes in and can help each other out while we're laughing. So I think that's enough for me. I'm gonna upload this to YouTube as well, and then I'm going to it should be up on Twitch. It stay on Twitch for I think 14 days. So there it is, multicast over IPSec VPN using the GRE tunnel to get that multicast traffic to go over unicast IP transport. I should be streaming again on Wednesday. I'm either going to stream or I'm going to do a premiere and redo my OTV stream that I did before. I may put that one back up. Or, depending on how work plays out, I've actually been, I may expand that OTV and I may add VXLAN and EVPN with it. So stay tuned. You never know what you might catch. So stay tuned. See you next time here on Big Abe's Network Emporium. Later, guys.